Hi everyone. In this video, we're going to talk about the tangent ratio. It's a trigonometric ratio, and this is part one of two videos where we're going to examine how to use the tangent ratio to solve problems. This video in particular just focuses on the definition of a tangent and actually finding the tangent ratio in right triangles. To begin this lesson, I want you to take a look at this diagram, which hopefully looks kind of familiar from section 7.4, where we learned about special right triangles. I want you to take a moment to identify which angle has to be the 60-degree angle. And then I want you to identify the ratio of the side opposite of the 60-degree angle to the side adjacent to it. So hopefully you were able to identify that angle A is the 60-degree angle here. The square root of 3 is the longer leg here, which is across from the 60-degree angle. If I want to look at the ratio of the side opposite the 60-degree angle to the side adjacent, well, the side opposite it is the square root of 3. The side adjacent to it is 1. So the ratio of the side opposite of the 60-degree angle to the side adjacent to it is the square root of 3. In that last problem, you looked at a very specific 30, 60, 90 right triangle. Let's look at our generic one, which we know looks like this. The short leg is across from the 30-degree angle. The long leg, which is across from the 60-degree angle, is the short leg times the square root of 3. And the hypotenuse is twice the length of the short leg. Take a moment to find the ratio of the side opposite of the 60-degree angle to the side adjacent to it. So when you do that, side opposite the 60-degree angle to the side adjacent, side opposite is this x root 3, side adjacent to it is this x, and as you can see, these x's cancel out. And we're left with the square root of 3. So it's not just in that specific example that the ratio of the opposite leg to the adjacent leg of the 60-degree angle ends up being the square root of 3. It turns out that's the case for all 60-degree angles in a right triangle. This brings us to the main point of this lesson, which is a trigonometric ratio. And we've been talking about one specific one so far, which we'll get to in a minute. But a trigonometric ratio is the ratio of two side lengths in a right triangle. Trigonometric ratios are described in terms of trigonometric functions in relation to angles. We're going to learn about 3 different kinds of trigonometric ratios in this course. Today we're going to start with one specific one. And that specific one is the tangent ratio. The tangent ratio is defined as the ratio of the leg opposite of that angle to the leg adjacent to that angle in a right triangle. Each angle has its own unique, well, not unique, but its own tangent ratio that never changes. So no matter what, the tangent of 60 degrees is always going to equal a certain number. And we actually found what that was going to be. We found that the tangent of 60 degrees, we were looking at the ratio of the side opposite to it to the side adjacent to it. And we found that ends up being the square root of 3. So each angle has its own tangent ratio that never changes, and a tangent ratio is a trigonometric ratio. This is the formal definition. Take a moment to put this in your textbook, and I would strongly encourage you to include the diagram. So let's do a quick example where we want to find the tangent of angle S and the tangent of angle R. This is the notation for it. TANS, that tells us we're talking about the tangent of angle S. TANR tells us we're talking about the tangent of angle R. So we abbreviate tangent with TAN, and the parentheses indicate what angle we're trying to find. So let's focus on angle S to start with. This is angle S. In order to find the tangent of angle S, we need to look at the ratio of the side opposite to it to the side adjacent to it. The side opposite of angle S is 80. The side adjacent to angle S, the leg adjacent to angle S, is 18. Both of these can be divided by 2. So the tangent of angle S is 40/9. Let's look at angle R, the tangent of angle R. This is angle R. The leg opposite of angle R this time is 18. The leg adjacent to angle R is 80. And that simplifies to 9/40. Hopefully you noticed we did not use the hypotenuse at all. If you find yourself using the hypotenuse when you're finding the tangent of an angle, you're doing something wrong. Tangent ratios only involve legs. Take a moment to find the tangent of angle J and the tangent of angle K. Tangent of angle J, the side opposite angle J is 24, the side adjacent angle J is 32, and I can write this in simplest form by dividing both the numerator and the denominator by 8. So 3/4 is my answer to the tangent of angle J. The tangent of angle K, the side opposite angle K is 32, the leg adjacent to angle K is 24. Simplifying that gives us 4/3. Let's do one more example. Take a moment to find the tangent of angle J and the tangent of angle K. The tangent of angle J, opposite over adjacent, would have given you 8/15. Tangent of angle K, opposite leg of angle K, over adjacent leg would give you 15/8. You might have noticed this from the examples, but it turns out if two angles are complementary, which is exactly what we were working with, we had two non-right angles of a right triangle. They have to form 90 degrees together, so they're complementary. If two angles are complementary, then their tangent ratios are reciprocals of each other.